So drilling down specifically on the definition of a function. Again, if I take an X value and input it into the machine, it should render simply one Y value. That is the definition of a function. So you look at this example here. I input X, the output is 2X plus 3. No matter which X value I run through that. Even if I put 0, the result is 3, only one output. Every function has what's known as a domain and a range. Now we will be focusing predominantly on the domain in this class. The domain is the set of all values that are the X values. And again, you only want to see those X values occur once. The range, you only want to see those X values occur one time with different Y values. When we look at the range is the set of values that are the Y values. Looking at the function categories handout that was provided for you, you'll notice that it is listed the different types of functions you might encounter in this course. There are 3 different types of polynomial functions. You've got linear, quadratic, and any higher degree polynomial function. And examples are provided for you. Now, your typical linear function, its graph is, of course, a line. And the domain is typically all real numbers. And you'll see that it's also written in the notation negative infinity to infinity, which is the notation that we are becoming accustomed to in this course. For a quadratic, once again, we also have all real numbers. In fact, even higher degree polynomials have domains that are all real numbers. Once again, in this course, we will not be paying much attention to the range of these functions. We'll be drilling down and focusing on the domain. So for polynomial functions, we will always have domains that are all real numbers. Other function categories like radical functions, you will encounter situations where the domain now becomes affected. For odd numbered radical roots, so if we're talking about the cubic root like you see here, cubic root functions are also all real numbers because you can take the cubic root of negative numbers. But when you get into even numbered radicals, like the example you see here, you'll see that there is a restriction because you cannot have a negative value underneath a square root. So that we are able to conclude that, and we use interval notation using the rectangular parentheses. And as always, it's open-ended to infinity. So you'll see in the example here where we have the root of t minus 1. So it's all real numbers will work as long as the numbers are greater than or equal to 1. You can have 0 underneath a radical, but you can't have a negative. So you'll note that it's a rectangular bracket around 1, which means it is included in the set, and a rounded parentheses around infinity, because we always put a rounded parentheses around infinity. Also, with rational functions, we will encounter scenarios where there are going to be restrictions on the domain. So you'll note with this example here, we cannot have a value of 0 in the denominator because at that point, the function does not exist. The function is undefined at that point. Specific to the example you see here, x cannot equal -3 because that would give us a undefined location on the coordinate plane. The way we write that in interval notation is we use the rounded parentheses because the -3 is not included. We use the union, which is the set that is very inclusive, the right side up letter U in between, to say that it's all values that are less than -3 or all values that are greater than -3. And that's how that reads on this for this function. The other type of function you might encounter as well is an exponential function. For an exponential function, once again, we're back to all real numbers. So in summary, the only ones you really need to pay close attention to when it comes to the domain is when you're dealing with radical roots or rational functions.